This is lesson number 60, multiplying and dividing rational expressions. The question for today is, how do we multiply and divide rational expressions? Just as a reminder, a rational expression is the ratio of two polynomials. So this means it's a fraction with polynomials in the numerator and denominator. And because a rational expression involves division, the denominator cannot be equal to 0. And rational expressions have excluded values, meaning that any value of the denominator that will result in division by 0. So essentially, the denominator cannot be 0. And also recall from our operations with fractions lessons that in order to multiply fractions, you're going to multiply straight across. And in order to divide fractions, you're going to keep the first fraction and then multiply by the reciprocal of the second fraction. All right, so let's get into some examples. When you are multiplying or dividing rational expression, if there is any type of multiplication taking place, you have two options. You can simplify before or you can simplify after. So I'm going to show you what happens when you simplify before, and I'm going to show you what happens when you simplify after. In the end, you end up getting the same answer, but sometimes it's just easier to simplify before because you'll get easier numbers. So I'm just going to do the first time, I'm just going to do it regularly. And when I say regularly, I'm meaning I'm just going to do it how I know how to multiply fractions that we discussed when we talked about operations with fractions. So that means 6 times 15 is 90. Then I have c to the third because I have a c and a c squared and then a d. Divided by 5 times 8 is 40. Then a and d. And then I'm going to go through and simplify everything that can be simplified. The zeros will cancel, so that will leave me with 9 over 4. I have a c cubed at the top. The d's will cancel and give me 1 as well, and so I have an a at the bottom. Now I'm going to do the same problem again, but this time I'm going to simplify first and then multiply after I have simplified everything that can be simplified. So the first thing I know is that 6 is divisible by 2 and 8 is divisible by 2. 1 is in the numerator, 1 is in the denominator, so I can divide them both by 2. 2 goes into 6 3 times, 2 goes into 8 4 times. Then I have 15 in the numerator and 5 in the denominator, so 5 goes into 15 3 times, 5 goes into 5 1 time. I also see that I have a d in the numerator and a d in the denominator, so those will both become 1. And now I can multiply straight across. 3 times 3 is 9. C times c squared is c cubed. On the bottom I have 1 times 4 times a, which is going to give me 4a. So notice that my math was just a little bit easier when I simplified first, but of course it is really up to you. You do not have to simplify first. Either way will work because if you notice, both answers are exactly the same. Now, on this problem, it is division. So when we are doing division, we have to first start off by keeping the first fraction and then multiplying by the reciprocal of the second fraction. So I'm going to have 18 xy to the third over 7a squared b squared times 35a squared b over 12x squared y. And now, because these numbers are fairly large, I'm going to go through and simplify whatever I can simplify. So 7 goes into 7 1 time, and it goes into 35 5 times. 6 goes into 18 3 times, and it goes into 12 2 times. I have an a squared on the top and an a squared on the bottom. Those are both going to become 1. I have a b squared on the bottom and a b on the top. So b squared is really 2b. So I'm going to take away the square, leave the b, and that's going to cancel with the other b. So those will both be 1. I have an x on the top, x squared on the bottom. So the x on the top will cancel with the x squared. And then I have a y cubed and a y. So this y cubed will become a y squared. And then the y on the bottom will cancel. And so then when I look across the top, I have 3 times 1 is 3. Y squared, 3y squared, times 5 at the top. And then on the bottom, I have 1 times b times 2x. And then when I go ahead and simplify that out, that's going to be 15y squared over 2bx. And then for those people who have a hard time seeing the simplifying, I'm going to go ahead and do it the other way just on this example to help you out. So 18xy to the third over 7a squared b squared times 35a squared b over 12x squared y. Now, I'm going to have to get my calculator because these are some large numbers. So 18 times 35 is going to give me 630. And then I have an x, y cubed a squared b. And then the denominator, 12 times 7 is going to give me 84. Then I'm going to do x, y first because they will line up. So x squared, y, a squared, b squared. And then I have to simplify from this point, the x and the squared. The 3 becomes a 2 and the y. The a's cancel, the b squared and the b. So now I have 630 divided by 84. When I put that in my calculator, I get 7.5. I know 7.5 is a fraction, is 15 over 2. And then at the top, I have y squared. And at the bottom, I have x and a b. So again, I ended up with the same answer. Just the math was a little bit more difficult because I didn't simplify in the beginning. So you have that option to simplify in the beginning or simplify at the end. You decide. Next, so when I get to examples like this one, the first thing that I want to do is I want to look and I want to see if there is anything that can be factored. Because if there is something that can be factored, then I want to factor because then I can possibly eliminate some things. So when I look at x squared minus 6x minus 16, then I'm asking myself what multiplies to give me negative 16 and adds to give me negative 6. Well, I know 8 and 2 give me 16. I need it to be negative, so the x needs to be negative. So that means that's going to factor to x minus 8 and then x plus 2 in the numerator. And then over here, I have x minus 8. So I'm going to put an x minus 8 at the top as well because that's what I see here. And then in the bottom, I'm going to look and I'm going to see what multiplies to give me 64 and adds to give me negative 16. That's going to be negative 8 and negative 8. So that's going to be x minus 8, x minus 8. And then over here, what multiplies to give me 6 and adds to give me 5. That's going to be a 2 and a 3. So that's going to be x plus 2 and x plus 3. And so now that I have factored everything, now I can look to see what things that I can find in the numerator and the denominator that are similar. So I have an x minus 8 and an x minus 8. Those both will become 1. I have another x minus 8 and another x minus 8. Those both will become 1. And then I have an x plus 2 and an x plus 2. Those both will become 1. So then in the numerator, I have 1 times 1 times 1, which is 1. And in the denominator, I have 1 times 1 times 1, which is 1. And then times x plus 3. And there's my answer. So when you can factor, it is better to factor first to see if there is anything that you can eliminate. Let's look at another one. All right, so when I look at this one, one thing that I know is that the first thing that I want to do is I want to factor it so that I can come up with some possibly or hopefully something to eliminate. So x squared minus 16, I know is the difference of two squares, and that factors to x plus 4, x minus 4. And then the denominator, 12y plus 36 is, I can do greatest common factor. I can factor out of 12, and then 12 times y will give me 12y, and then plus 3 will give me 36 because 12 times 3 is 36. This is a division problem, so then that means I'm going to flip the second problem. So I want to look at the bottom first. So the bottom is asking me what multiplies to give me negative 18, but adds to give me negative 3. Well, I know 6 and 3 is 18. I need it to be a negative, so I'm going to make the 6 negative. So that's going to be y minus 6, y plus 3 now in the numerator because I had to flip it. And then I want to know what multiplies to give me 32, as to give me negative 12. I know 8 and 4 is 32. I need them both to be negative for negative 12. So that means I'm going to have x minus 8, x minus 4. And so now I want to go through and see what things I can eliminate. So I have a y plus 3 and a y plus 3. Those both will become 1. I have an x minus 4 and an x minus 4. Those both will become 1. So then in the numerator, I am left with x plus 4, y minus 6. And in the denominator, I have 12 and then x minus 8. And you can leave it just like that. And one thing that we didn't talk about was excluded terms. So I want to get my excluded terms from, or my excluded values, from my original problem. So I know that in this problem, y can't be 0. And I know that over here, y can't be 6. And y can't be negative 3. And I got that from knowing that this factored to this right here. And I use those to get my excluded values. It says simplify. If it tells you be sure to include the excluded values, then definitely make sure you do that. So a complex fraction is a rational expression with the numerator and or denominator that is a rational expression. So basically a complex fraction is going to be a fraction within a fraction. So here are some examples of complex fractions. And so what I'm going to do is I'm going to take my highlighter and I'm going to go over it just a little bit thicker so that you can see I have this as my actual fraction bar, and I'll do it all the way across. This is my actual fraction bar, so I can see that I have C over D as another fraction within the fraction in the first one. And then I have here in the second one, here's my first fraction at the top, second fraction at the bottom. So to simplify a complex fraction, all you need to do is first rewrite it as a division of two expressions. And once you rewrite it as the division of two expressions, then it looks just like the problems that we've already been doing. So we're going to do a couple of those examples and then we will be done. So here I have a plus b over 4 divided by a squared plus b squared over 4. So the first thing I'm going to do, I'm going to rewrite it. So then it will become a plus b over 4 divided by a squared plus b squared over 4. And now it looks like problems we've seen before. And since this is division, I'm going to keep the first one, a plus b over 4, and multiply by the reciprocal of the second one, 4 over a squared plus b squared. And then these two 4's will cancel to both give me 1. And so then I'm left with a plus b over a squared plus b squared. And just as an FYI, a squared plus b squared cannot be factored. All right, last one. All right, so we have x squared over x squared minus y squared divided by 4x over y minus x. So the first thing I'm going to do is rewrite it. So that's going to be x squared over x squared minus y squared divided by 4x over y minus x. And again, this is division, so I'm going to keep the first fraction, x squared over x squared minus y squared, and then multiply it by the reciprocal of the second one, so y minus x over 4x. And x squared minus y squared can be factored. So that's going to be x squared over x plus y, x minus y, and then times y minus x over 4x. And if I look at this point, it looks like, oh, there's nothing that I can simplify. There's nothing that I can work out. So there's no point in me doing this problem, except for all I can do is this 2 and this x, and that will cancel. But there's more. Remember, when we talked about simplifying, we talked about pulling out a negative so that we can make things look more factorable. So I'm going to take this problem, this portion of the problem, and I'm going to pull out a negative to help me out. So I have a pull out a negative, and then negative times what is going to give me a positive x. That's a negative x. And then negative times what is going to give me a negative y. That's going to be a positive y. So then that is a negative x plus y. And I can switch that around to be negative and then y minus x. And so it now looks like what we have. So I'm going to rewrite that with what I have simplified. So I have an x on the top and a y minus x. And in the denominator, I have x plus y. I have this negative here, so I'm going to put that in front. And then I'm going to put this y minus x. And then I have a 4. I'm going to slip that 4 in right in the front so that the coefficient will be in the beginning. Then I can cancel out those because they both give me 1. And I'm left with an x in the numerator. And in the denominator, negative 4 times x plus y. And there you have it.